Hi everyone, in this video I will mention horizontal tangent lines. So what does horizontal tangent line mean? It means that the line that's touching the particular point is horizontal, so its slope is 0. So horizontal tangent line means slope of this line is 0. So slope, the derivative of the function at that particular point is 0. So like these two examples, we have local extrema, so the slope is 0 at that point. We don't have an extrema, but still the horizontal tangent line is horizontal, so derivative at that point is 0. Let's take a look at some examples. An exercise question: find points of horizontal tangent lines to that function. So we need tangent line, so we should find the derivative first. So f prime of x equals derivative of x to the fourth, 4x cubed, minus derivative of 8x squared, 16x, plus derivative of 2, 0. So I'm not taking derivative. So if there is horizontal tangent line, then I know that slope, which means derivative, is equal to 0. So I need to equalize the derivative to 0. Take the common factor out, which is 4x. So x squared minus 4 is equal to 0. Either 4x is 0, then x is 0, or x squared minus 4 is 0, then x squared is 4, x is plus and minus 2. So I have three x values. That makes the slope horizontal tangent line. That makes slope 0, the tangent line horizontal. So let's find their corresponding y values, because we are asked to find points. So we need x and y. X is negative 2, x is 2. So when x is 0, what's my y? My y is equal to, look at the original equation, 0 to the fourth minus 8 times 0 squared plus 2, which is 2. That's my first point. Second point, substitute negative 2 for x, which is, here I have 4, here negative 2 squared 4, 4 times negative 8, negative 32, 16 minus 32, negative 16 plus 2, negative 14. f of 2, the function is even, so by changing the sign of x will not change anything. The result will be still negative 14. So the points are 0, 2, negative 2, negative 14, and positive 2, negative 14. So those are the points of horizontal tangent lines to this function. Another question, another exercise question: find horizontal tangent line. Horizontal tangent line means slope, derivative to be equal to 0. So take derivative, f prime of x equals. Let me rewrite the function before I take the derivative. Let's move variable to numerator to use power rule. Using power rule is easier than using quotient rule here. That's why I chose to move it to the numerator to use the power rule. So put down the exponent down in front as a coefficient, negative 2x. Reduce the power by 1, negative 3. So it's negative 2 over x cubed. That's my derivative. So what values of x make the derivative 0? Negative 2 equals 0 is not true. So there's no x value that makes derivative 0. Okay, since there is no x value that makes derivative 0, there is no horizontal tangent line. Okay, there is no, it doesn't have to have, the function doesn't have to have horizontal tangent line, so there is no here. Another question, another exercise question, it has trigonometry in it. So find horizontal tangent lines. Find the derivative. Derivative of x is 1, derivative of sine is cosine, equalize it to 0. Bring 1 over, cosine x is minus 1. So what is x? X is cosine inverse of minus 1, which is 180 degree. So 180 degree is 180, which is pi, in this interval from 0 to 2 pi. Yes, it is actually. Pi is in between. Pi is in the given interval. It's important to check the interval. Sometimes the value that we find will be outside of that interval, so we will say no point of horizontal tangent line. Since our result is inside that given interval, we have horizontal tangent line. So what is the corresponding y value? So what is y? Y is, substitute pi for x, pi plus sine pi. Sine pi is 0, 0 plus pi pi. So our point is x comma y. X is pi, y is also pi. So pi pi is horizontal tangent line. All right. So there are some questions that is only asking about number of horizontal tangent line. So we don't need to solve the question entirely. What we need to do is checking if the checking the discriminant. So if derivative of a function is quadratic, then we can check discriminant. If discriminant is negative, you know the rule. If there is negative, no horizontal tangent line. If there is 0, there is one horizontal tangent line. If discriminant is positive, there are two solutions, so two horizontal tangent lines. So if the derivative is quadratic, no need to solve, no need to factorize, simplify your stuff. Just check discriminant. So decide the number of horizontal tangent lines accordingly. For example, in this ministry question, and there is an exercise question in the book in section 2, exercise 70. It's talking about these rules. So here's an example of this situation. This came in as a ministry question once. So the original functions are given as all cubic. So their derivative will be all quadratic. Option A. I don't have enough space here. Let me write down here. Option A. Derivative of each, 3 down in front, 3 cancels, x squared minus 3 times 2, 6x, here plus 9, 0. So this is the derivative being 0. So x is the common factor out, x minus 6 is 0, x is 0, x is 6. So I have two horizontal tangent lines. Question is asking about having no horizontal tangent line. We have two, so it's not the answer. Option B. Take derivative. F prime of x is 3x squared minus 3 by 2, 6x plus 3. When it is 0, what's the discriminant? B squared minus 4ac, right? Your b is negative 6. Negative 6 squared minus 4 times a, 3 times c, 3. 6 squared, 36, minus 4 times 3 times 3, 9. 9 times 4, 36, which is 0. Discriminant being 0 means there is one horizontal tangent line. There is one solution. Okay, check the other options. Option C, derivative is 3 times 2, 6x squared minus 3 by 2, 6x. We have horizontal tangent line here. When I take 6x as a common factor, x remains here, 1 remains here. So x equals 1 and x equals 0 are horizontal tangent lines. We have two horizontal tangent lines. Last option, derivative of 2x cubed, 6x squared plus derivative of x, 1 being 0. Move 1 to the other side, x squared being negative 1 over 6. X squared being negative is impossible, so there is no solution, no horizontal tangent line. Okay, so in option B, I used these rules because I had a quadratic function which has all three terms a, b, c. So I didn't factorize the equation. I applied this rule. Otherwise, we should solve it. Okay, now one more thing about horizontal tangent line. Some questions will ask us about the number of horizontal tangent line. The questions will not ask us to find horizontal tangent line. It will only ask the number of horizontal tangent line. So, first one, test prep 7. Which one is the correct number of horizontal tangent lines? So, in either case, whether it asks about the horizontal tangent lines or its number, we should find the derivative, equalize it to 0. So, let's simplify this function before taking derivative because applying power rule is annoying. So let's simplify. X squared minus 1 times x squared plus 1 is like a minus b times a plus b, which is difference of two perfect squares, right? So first one squared, x to the fourth, x squared squared, x to the fourth minus second one squared 1. This is the original function written in simplest form. Now I can take its derivative. It's much more easier. Derivative of x to the fourth, 4x cubed, derivative of 1 is 0. So that's my derivative. So derivative to be 0 will give us the horizontal tangent line. So 1 4x cubed is equal to 0, x cubed is 0, dividing both sides 4. Cubic, take cubic root of both sides, x is 0. So what's the answer? Answer is not 0. The question is asking about number of horizontal tangent lines. We just got one number. So there is one horizontal tangent line. So be careful. In the options, we may have 0, 2. It's not asking about the value of horizontal tangent line. It's asking about their number. So we have only one, not 0. One last question, and I'll finish this lesson. What's the correct number of horizontal tangent line? So take its derivative, f prime of x equals, there's power, bring down the power in front, multiply it by derivative of the base, which is 3, so 3 by 2, 6, 3x minus 9, equalize it to 0. So equalize the derivative to 0. Divide both sides by 6, 3x minus 9 is 0, bring 9 to the other side, divide by 3, x is 3. So what's the answer? Answer is not 3. Be careful. 3 is the value of x horizontal tangent line. It's the value of horizontal tangent line. The question is asking about number of horizontal tangent line. We see only one. So there is only one horizontal tangent line. All right.